Okay, up until this point, we've done some practice. Well, back in Algebra 1, we've done practice with graphing quadratics in standard form, which is ax squared plus bx plus c. But now we're going to start working with graphing quadratics in vertex form. And this is actually a lot easier than graphing in standard form. We don't have to find negative b over 2a. We don't have to do any of that stuff. All we have to do is just look at the equation and we can figure out where things are. So let's break this down. So we have f of x equals a times x minus h squared plus k. Now if we have a quadratic in standard form and we want it to be written in vertex form, we would complete the square. That's how we would get it there. But we're not going to worry about that this time. We're just going to worry about graphing in this form, okay? So whatever a is, this is our leading coefficient. We want it outside of the parentheses. This indicates a reflection across the x-axis or a vertical stretch or compression. So the way we know if a is a reflection is a is negative. If there's a negative sign, we know there's going to be a reflection. Okay? A vertical stretch is if a is bigger than 1. And a compression is where a is less than 1. All right? Now say there's a coefficient right here. We'll call it c. If there's a coefficient inside of the parentheses, that indicates a horizontal stretch or compression. So in order for there to be a horizontal stretch or compression, horizontal stretch is if c is less than 1 and the stretch is by a factor of 1 over c, and we'll talk about that in a little bit. So if there's a horizontal compression, then c is going to be bigger than 1, and it's going to be by a factor of 1 over c. So whatever it's inside, it's horizontal, and it kind of flips things over. So just like outside here, if k is on the outside, if you're adding or subtracting, that means you're going up or down vertically. If you have a minus h or a plus h on the inside, you're going left or right horizontally. So minus h means you're going right. Plus h means you're going left. So that's how you figure out what kind of transformations have been happened to your graph. So let's do an example or two here. So the parent function f of x equals x squared is vertically stretched by a factor of 3 and translated 4 units right and 2 units up to create g. Right, g in vertex form. So we're going to start out with g of x. Now the first thing they tell us is it's vertically stretched by a factor of 3. So we know that that 3 is going to be outside here. 3. Translated 4 units right. So we're going to take our x, and we're going to subtract 4 because it's to the right. X minus 4 squared, 2 units up, plus 2. And that's how you do that. Okay? So this one over here, circle the function that produces the widest parabola. So what you're going to do is you're going to look at this guy. That makes it a vertical stretch or compression. It's going to change how wide or narrow your graph is. So I want to tell you something right now, that the smaller the number, the wider the parabola. Okay? The smaller the leading coefficient, the wider parabola. So if we were to look at all these, this is, excuse me, 2x squared minus 4, negative 1/5 x squared plus 2, and 2 times x minus 1 squared. Well, I know if I combine these two, that's going to give me a 2x squared, right? So these two are going to be the same, and we want the smallest number, so widest is the smallest a, because really that's what we're looking for. We're looking for a. So really, this is the widest one. Even though it's flipped upside down, negative 1/5 is smaller than 2x, but we're looking at the absolute value of a. So 1/5 is smallest out of all of these. So that produces the widest parabola.